Alright, so now that you've learned kind of some of the basics related to circular motion, we're going to get into the concept of circular speed. And there's a few different ways that you can calculate this. Okay? So, first thing, and we've talked about this, is linear speed, which specifically when working with a circle is actually called tangential speed. But this is similar to what we've dealt with already in this class. You're finding it in meters per second. It's related to distance divided by time. The key, though, because you're moving in a circle, your distance is actually your circumference, okay, which is just the outside length of the circle. All right, so circumference is equal to 2 pi r, which is why we get that in our velocity equation right here. Velocity is just speed with a direction. You can treat those words more or less interchangeably at this point. So, it's going to be your circumference divided by your time. So, velocity is 2 pi r divided by t. And then this is what it would look like if you were rearranging. Okay? So, just so that you know where those things come from, if we want to rearrange for t, first thing is, right now, as the equation is written, you have 1 over t. Alright? So, in order to rearrange that, you have to get t out of the denominator, or out of the underside of the fraction. Okay, so make sure you start by multiplying both sides by t. Okay, so times t, and you end up with Vt equals 2 pi r, and then you want to get rid of the velocity, and since that's being multiplied, the opposite is dividing, and that's how you get this one. T equals 2 pi r divided by v. Okay, and then our next one, solving for r, a little less difficult. If you go back to our original, v equals 2 pi r divided by t, first step is still getting the t out of the bottom because you need to get rid of that to get r by itself. So you have vt equals 2 pi r, and then you divide by 2 pi in order to get r by itself. So that cancels, and you get Vt divided by 2 pi. Okay? Important things to know. So, linear speed was like what we did when we went outside and the whole class tried moving around in a circle. It is dependent on the radius, and you can see that in the equation. Alright, because V equals 2 pi r divided by t. So the bigger the radius, the bigger the circumference is going to be, which means the more distance you end up going. Alright? If you think about the tire, if you're right here, your distance is much tinier than, say, the tread of the actual tire out here. Okay? So, linear speed is dependent on the size of the circle. Alright? The bigger the circle, or the further towards the outside of the circle, the bigger your radius. So therefore, when radius goes up, velocity goes up. Okay? So, example of this, you walk a track in 5 minutes. If the radius of your track is 64 meters, what is your linear speed in meters per second? So we've got a time of 5 minutes, distance of 64 meters, but remember that's our radius. So we know r equals 64, we know t equals 5 minutes, which in seconds, since we need to find it in meters per second, that's going to be 5 times 60, which is 300 seconds. Try to get that s in there. So we know velocity is 2 pi r divided by t, which is going to look like 2 pi times 64 divided by 300, and 64 times 2 times pi ends up giving you 402 divided by 300, and is 1.34 meters per second. Okay? So that's just an example of how you could do stuff like this. A difference, or a very distinct speed, that actually isn't dependent on the size of the circle is something called rotational speed. All right? In a basic sense, you're literally measuring how many rotations you do per minute or per second. Okay, so that's how many times the circle goes all the way around in a given period of time. All right? This is why when we went outside and did that rotation activity, I asked you guys if anyone rotated more. Everybody, as long as the circle is actually stuck to each other, like if you think about a wheel and its spokes, they all have to turn at the same time. So they all have the same number of rotations, no matter where you are on the wheel. All right? So rotational speed is the same anywhere on a circle. All right? It's the linear or the tangential speed that changes based on the size of the circle. Remember, you can do it rotations per minute, rotations per... So, an example of that is a car tire rotates 300 times in 15 minutes. So you can do rotations per minute, all right, which is going to be 300 divided by 15, which is 20 RPM. I don't know if you guys have ever heard or seen that on a car, but RPMs is how many times your tires are rotating in a minute. All right. Now, if you want to do that in rotations per second, all you have to do is take your 15 minutes, multiply by 60, and you get 900 seconds. So you're going to do 300 rotations divided by 900 seconds, and you're going to get 0.33. .33 RPS. Okay? So RPM is rotations per minute, RPS is rotations per second. Okay? So angular speed is related to rotational speed because, again, it's going to be the same no matter where you are in the circle, but it's the how much angle you move per second. Okay? So it's angle per second. Now, angles can be measured in degrees, or angles can be measured in radians. Okay? That's where that new unit radians comes from. So, remember, a rotation, so one rotation equals 360 degrees, or one rotation equals 2 pi. Okay? You want to make sure you're familiar with those. So how you could apply this to a thing. Same sort of problems. Car rotates 300 times in 15 minutes. What's the rotational speed in degrees per second? So what we need to do is take our 300 rotations, multiply that by 360 degrees to get the total number of degrees. So that's going to be 300 times 360, which is 108,000 degrees. All right. And then, again, it's 15 minutes, but we want it in seconds. So you do 15 times 60, which is equal to 900. And then you take your degrees and your seconds, and you divide them. So 108,000 divided by 900 is 120 degrees per second. Okay, if it's easier, you could also write this as 120 degrees per second. If that's going to stick out more to you, this would probably actually be better. That way you never accidentally think that that little degree sign is a 0. So I'll write it out as DEG divided by S. And then, same thing. We were rotating 300 times, 15 minutes, but we want to know radians per seconds. So again, every rotation is 2 pi, so you do 300 times 2 pi, which is 600 pi. My suggestion, leave the pi in there. Don't actually multiply it out until the very, very end. That way you don't have to work with so many decimals. Okay? And then, again, 15 times 60 is 900 seconds. So we've got 600 pi radians, and then we have 900 seconds. We're going to divide those two numbers. So this would be the step where you actually include the pi, so that you get an actual number, Or you could even carry it through this, because 600 divided by 900 is going to be 0.67 pi radians per second. Or if it makes you feel better about it, you can do that to actually multiply it out by pi. And it would be 2.094. You just leave off the 4. Radians per second. Alright? But pi, because it has so many decimals after it, is sometimes better off being left as pi in problems. Okay? Because this number would actually be 2/3 pi. As far as on a quiz, you'll either, if it's multiple choice, you'll see that the pi is left in there, or if there is no pi left in there, then you can just multiply it out. If it's a written quiz, so there are no multiple choice answers, I would accept either one of these, as long as you remember to write the pi on this answer. Okay? So, that is the end. Remember to do your online assignments by 7:20 a.m. tomorrow. Okay? I'll see you in class.